I realized that after you ordered. I did.
What do you think? Easier than the first one? Much easier than the first quiz? Okay. The next one might be harder because the next one were also related to network. So this one is only a crypto basics, so it might be easier. Okay. So
In that case, it was really hard.
So I'm not going to review the quiz today because there are several other students that are going to take a makeup quiz. So we are going to review it next week. This week we have been talking about IPSec, and today we will have the last class on IPSec. So next week we are going to move to the very interesting stuff is TCP security, the transport layer security. So we talked about the IPSec architecture, policy, and the different modes. We talked about two protocols, Authentication Headers and ESP. So a very important concept in IPSec is this thing called the security association. So we know that ESP and Authentication Header, both of them, they are using symmetric key crypto, which means we somehow need to manage the secret key, distribute the secret key. And the security association, part of it, is the key. So we talked, the authentication header uses keyed MAC to protect the integrity and the authenticity of the packet. And also ESP uses encryption, symmetric key encryption to protect the confidentiality of the key. So the only missing part is how to share this security association, which means how to share the key, how to share the metadata of the key. So there are basically two ways to do it. First, we can do it manually. Like we discussed in crypto basics, you can manually distribute the keys through another offline channel or another secure channel. However, this is not practical. This can only be used for small environment, small corporations. But if you really want to build secure communication among any two hosts on the internet, we need some kind of a dynamic, automated way to negotiate keys. Fortunately, we know Diffie-Hellman protocol can be used to negotiate the key. So there is a protocol. I'm not talking about Diffie-Hellman. I'm talking about the network protocol called the Internet Key Exchange Protocol. So this protocol is used to exchange the keys. So under the hood, it is using Diffie-Hellman algorithm. So, but this protocol is a general purpose key exchange protocol. So it is not only used for IPSec, but it is widely used only for IPSec. So this protocol basically, it can exchange security associations. So it doesn't really rely on authentication header protocol or ESP. Because this is a standalone protocol, and to perform this protocol, two communication parties, they have to have their own standalone programs. It could be a program, it could be a daemon, and this daemon will use UDP packets. Usually it listens on port 500. So those, the IKE programs on two hosts, they are going to negotiate the security associations on the two hosts' behalf. And then it will store the security associations in previously we said the security association database. So because this is a standalone protocol, itself could be the target of attacks. So there are many expected features for this protocol itself. Obviously, itself should be secret, should be maintain the confidentiality. It can maintain authenticity. And the authenticity here can be maintained using public key infrastructure. So even though we are using Diffie-Hellman, even though IPSec itself is using symmetric key crypto, but the protocol to exchange the secret key may use a public key certificate to prove the identity of each host. And it has to defend all kinds of replay attack, DOS attack. We will skip this part. So one thing this protocol has to deal with is, we talked to Diffie-Hellman, even in the quiz, we asked the question. One problem with Diffie-Hellman is there is no authentication on two parties. So it is subject to man-in-the-middle attack. So that's why in this internet key exchange protocol, they bring this authentication of two hosts into this picture. So to do that, they are using certificate. So it's very complicated protocol. We're not going to the details, but I will share some big pictures, how we are going to use IKE and also use IPSec. Let's say we have two hosts, host A, it could be a host, it could be a gateway, and another host or gateway B. They want to establish a secure channel using IPSec. So the first thing they need is, both of them, they need to run the IPSec stack, which is the software to understand the IPSec protocol, to construct IPSec message. And normally, usually those IPSec stack, because it is actually at network layer, it is in the operating system kernel. It's not in the user space. Besides that, they should have another IKE program, IKE daemon. So this daemon, usually they run in the user space, because actually it is using UDP, it runs on application level. So whenever host A or gateway A wants to send an IPSec packet to host B, it will first trigger this IKE daemon, ask this IKE daemon to negotiate a key with host B's IKE daemon. So they will use the enhanced Diffie-Hellman algorithm with authentication to negotiate some security policy, something like what kind of algorithm the IPSec should use, what kind of hash function the IPSec should use, and also security associations, which basically is the key and the metadata of the key, the index of the key. Then both of them, they will store these security policies and security associations in their database. Remember, there are two databases. One is a security policy database and a security association database. Both of them will store this. Then host A wants to send an IPSec packet to host B. It will query its own policy database and association database to say how I should encrypt this packet or authenticate this packet. Based on that, the packet is modified and sent over to host B. And host B will use the packet. In the packet, there will be the security association, security parameter index, not the key. They will search the security parameter index using its own database so it can get the secret key, because the secret key was negotiated before using Diffie-Hellman at this step and stored in its local database. Using that key, host B can do authentication using keyed MAC, or it can decrypt that message also using that same key. So basically, this is a big picture of the IPSec, how it works, and how the key got changed. And remember that this IKE, the Internet Key Exchange Protocol, is not really part of the IPSec, but it is mainly used only for IPSec. Any questions? Is it clear?
I got a question.
Sure.
So IKE just it uses the DH 50 home and stuff,
Yes.
and that's just to exchange a key.
Yes. Exchange is a secret key, but it's an enhanced version of diffie-Hellman because diffie-Hellman has a man-in-the-middle attack problem.
Okay.
So they bring public key certificates there to authenticate those before exchange them. No other questions?
So is IKE asymmetric then?
We do not really call diffie-Hellman symmetric, right? But diffie-Hellman cannot be used for encryption. It can only be used for negotiate keys. So usually we do not call it public either. Some literature will call it public key, but it's different from RSA or other languages. Okay, that's all for today. So next week we are going to talk about the TCP.